Okay, class, we're going to learn about similarity with parallel lines. That's what we're going to learn about, aren't we? So if you have a picture that looks like this, okay, can you tell me that these two triangles are similar? This one and this big one. Why?
Because the lines are parallel.
No, they not very good. Okay. So what Kevin just said is correct. Is that because these lines are parallel, this angle has to be congruent to this angle, right? And this angle has to be congruent to this angle, and therefore this little triangle has to be congruent to that big triangle, right? So say I know that this is 4, and this is 3, and say I know that this is, we'll pick some bad numbers, 5, and this is 4. Can you write a proportion using those ratios?
3 is to 5. 4 is to 5 is 3 is to 4.
4 is to 5 as 3 is to 4. I don't know if that's true.
7 is to 4 as 9 is to 5.
Okay, because this small triangle, see, then you just be comparing a small triangle to a piece of a triangle, right? Okay, so 4 is to what?
4 is to 7.
7 as 5 is to 9. Okay, which means that, we don't have to. So that's the proportion that works. Now, let's see something else, okay? Is it true so instead of calling this 4 and 3 and 5 and 4, okay? I'm going to call this as A, B, C, and D. So Natalie wanted to say that A is to C as B is to D. But we said that that's not necessarily true, right? Okay? So let's see. Maybe it is true. And we're going to prove that algebraically. Watch. So if I were doing this correctly, A is to what? What would I call this whole side?
AC.
A plus C is B to B plus D. Okay? And I'm going to cross multiply, and I get B times A plus C equals A times C plus D. And I'm going to use the distributive property. AB plus BC equals AB plus AD. I did that right?
Yep.
Okay. Now, algebraically, what you can do is take out a B out of both of these. B times A plus C. Oh, I'm going backwards again, okay? So, oh, look, AB disappears from both sides. Thank you. That's what I meant to do. I didn't look at my. So now I know that BC equals A times D. And now, hold on. Now, what I'm going to do is I'm going to divide both sides by something. I'm going to divide this side by C and by D. And I'm going to divide this side by C and D. I'm allowed to do that, aren't I? Why?
Where did you
get those? Like, do you just randomly do them?
Because I'm looking at this and I'm trying to prove it. Yeah, I just randomly picked that because now, look, just chill. Just
If you don't answer our questions, we're not going to get it.
B is to D. You don't have to get this. I'm just showing you where it comes from, okay? A is to C. So what I just did is I proved, see how this says A is, we want to know is A over C equal to B over D? So what I did is I proved that that is always true because this is the side of this smaller triangle, and A plus C is the side of this big triangle, right? B is the side of this triangle, and B plus D is the corresponding side of that bigger triangle, right? Then I cross multiplied, and I distributed through, and I subtracted like terms on both sides. Then how do I know how to divide by C and D? Sometimes you have to play with the letters and make things work, okay? Could I divide by A and B? I could, but I don't think, it wouldn't give me this over here.
What
See?
does this do for us then?
What does this do for you?
You put the numbers back.
Hold on, okay? Can I put the numbers back? Sure. So instead of doing A over A plus C equals B over B plus D, now all I have to say is when you have a parallel line and two triangles and a triangle, you're allowed to say that this piece is to this piece as this piece is to this piece, okay? And that's kind of where what I was trying to prove is always true. So for example, say now I have a new piece of paper and I got my cool tool on my thing here. I'm running out of space too. So say I have a triangle like this. Ooh, this is a bad triangle. Okay? But it'll work because I have the tools. And then say I know that this is parallel. Okay? Even though it doesn't look like parallel. And I have some numbers that might work or might not work. Say I know that this is 48 and this is 36 and this is 60 and this is y. So it's going to be a proportion to find y. Yeah, so all you have to do is go 48 is to 36 as 60 is to y. And then, yeah, very good. So who said that? Very good. Harry reduced that in his head, right? So what number do you divide into both of those? 12. So 12 goes in there 4 times, and 12 goes in there 3 times. So he reduced this to 4 to 3. And then when you cross multiply, you get 4y equals 180, right? And you get y equals 45. So this side would have to be 45. Okay? So before, what would also be true is that 48, if I'm just using the similarity, 48 is to, what would that be? 84? 84? As 60, but then instead of calling this y, you'd have to call this 60 plus y. And you could do it that way, but that way's more work, right? So it's kind of nice to, the one thing you have to be really careful of not doing, say you know that this side is like 12, okay? And this side is x. You cannot say 48 is to 36 as 12 is to x. You understand that? Because this is a piece of the triangle, whereas this is a whole side of the triangle. So 48 over 36 isn't equal to 12 over x. You could say 48 is to 84 as 12 is to x. Okay, so that would work, but not 48 is to 36 as 12. You could say that 48 is to 48 plus 36, which is where the 84 came from. This is 48 plus 36 right here equals 12 over x, because this is a whole side of that term, you see? So you got to kind of be careful with that. Okay?
Is this like a conjecture?
This is a conjecture. If you look on your conjecture sheets, ladies and gentlemen, let me find that. Geometry Advanced. What chapter are we in? Chapter 11. Chapter 11. Conjectures.
If the line parallel to one side of the triangle passes through the 2 other sides, then it divides the other 2 sides proportionally.
Yeah.
It's snowing.
It's kind of snowing. Wait! That doesn't have to do with...
I was.
Okay, so... so this is the...
C100.
C100. Yes? That's irrelevant.
This is a video.
Not
If
enough
a
to
line-
say that enough to-
If a line parallel to one side of the triangle passes through the other two sides, then it divides the two other sides proportionally. Can you guys just let me finish, please? Okay. Conversely, if a line cuts two sides of a triangle proportionally, then it is parallel to the third side. Okay. In other words, going backwards, if I were to go backwards, whoops, I want a new piece of paper. So if I were to go backwards and I see that, and I see a picture that looks like this, and they say 3, 6, 4, 8, even though it doesn't look like 8. Are these lines parallel?
No.
Are these lines parallel? Yes, because 3 is to 6, as 4 is to 8. It's equal to 1/2, right? 1 to 2. So that must mean that these sides are parallel. So that's what this conjecture right here says. Okay? The extended, mind your way. The extended proportionality conjecture says if two or more lines pass through two sides of a triangle parallel to the third side, then they divide these sides, two sides, proportionally. In other words, if I have a big triangle, why does it keep doing that? I don't know. Oh, let me go back. Let me go back to this, okay? Well, I'll just take a new sheet here. So, if I have a big triangle, big triangle, big triangle. That was a big, that's one big mama triangle. And I'm told this and this maybe, okay? And I'm told that all three of these things are proportional, right? Or, sorry, parallel. Then say, no, this is 3 and this is, I don't know, 6, and this is 4. Thanks, Madonna. And say, no, this is 4, and this is X, and this is Y. You can find all those things this way by saying 3 is to 6, as 4 is to X. So X would have to be what?
3.
X equals 3. No, 8.
No.
X equals 8. And then I could go on to say that 6 is to 4 as 8 is to Y, right? 6 is to 4 as 8 is to Y. So that would be, that's harder, right? That's 32 equals 6Y. So Y equals 5 and 1/3, I think? 5 and 1/3. Okay? So that's it. Okay? Now, there's one more thing that I got to teach you. Divide 8. So this is kind of a cool thing. Dividing up a segment. This is a compass thing, a construction. It's a segment, is that funny? Into congruent parts. Congruent parts. So if you don't have your compass, you should have one. Oh, here I go with the compass. That's not going to work very well.
Maybe you should pause this.
Maybe I should pause it. No, I'm just going to go for it.
Write this down.
Okay. Yeah. Well, I don't know if you have to write it down, but I would know it. Okay. So you have this segment right here, and I want to divide this up into 3 congruent parts. And you can divide it into 5 congruent parts, or 4 congruent parts. Divide it into 3 congruent parts. The way you do that is by first coming and making a ray going off here, probably longer than this segment. So here's a ray. Okay? Now you take your compass. Should I try to do this?
No.
Yeah, I'm going to try to do it. Okay? So I'm going to take my compass. Where's my compass? Toolbox. I'm going to find my compass. Okay? Ooh, there it is. Okay. Ooh, say ooh. And how did I rotate this again? How did
I'm
you guys
pretty
do
sure you
that?
pull it from here.
Pull it from here?
No, down.
No, the tip.
The tip. That's how
Let's
it's
draw.
No, I didn't want to draw it. There. Okay, so here I go. So you take your compass and you set it at some arbitrary setting. Arbitrary. but long enough so that I could fit 3 equal marks on here. So I'm going to make a mark. Drawing is right here, right?
Yeah.
Okay, so I'm going to make a mark here. Then I'm going to lift up my compass, and I'm going to make another mark. No, we didn't really do this. To make another mark here, okay? I'm going to pick up my compass. I'm going to make another mark here, okay? And now what I do is I get rid of my compass a little bit. And so what I have is a point here. All these pieces are congruent, right? This, and this. So this is congruent to this, and this is congruent to this. Now what I do is I take my straight line tool, or my straight edge, and I connect from this point to that end point. You see that?
Whoa.
Okay? Yeah, but you're not allowed to. You're doing it with your compass. No measuring. And now, because if I make an angle, I copy this angle to over here, and I copy that angle to over here, and I make 3 parallel lines. You understand? So, and I don't know if you remember. Do you guys remember how to copy an angle?
No.
Oh, I didn't think you did. Okay. Should I try to do it with my online compass? Hey,
We'll figure it out.
toolbox. Where's my toolbox? There we go. Compass. Come on, you guys. Just be nice. Okay, so I'm going to take my compass and flip it around, flip it around, flip it around. Here, okay. There we go. And I'm going to squish it a little bit. And then I'm going to come over here. I'm going to put the point. I'm going to turn it a little bit more. Put the point over here. I'm going to go, if you remember what we did. So now this will work. I'm going to spread it here. Okay, so now I'm going to make an arc here. Remember this?
No.
Pick it up. I make the same arc over here. I make the same arc over here, putting my point right there. Like that, okay? And now I'm kind of done, because where these 2 things intersect, so this point of intersection is kind of hard to see. This point intersects right there, and if I take my straight edge and I connect this point to that point, if I did it correctly, now my compass isn't perfect, and I connect this point to that point, all 3 of these lines should be parallel. It's easier to do with a real compass. So this should be parallel to this, parallel to this. That means that by our proportionality conjecture, if these 3 are equal, what has to be true about these 3 pieces? They're congruent as well. So what I did, again, is I took a segment, then I did a ray coming off that segment, and I divided it up into 3 pieces, made a triangle, and then I copied that angle, and then I should have 3 congruent pieces. All right, that's it. And remember, you heard it here on Mr. Leader's Leading Edge Geometry Math Channel. Thank you. Okay.